Hello and welcome. We're about to uncover a hidden journey that happens billions of times a day all around us. It's the incredible transformation electricity makes, from your wall socket, through that little power brick, and right into the heart of your favorite device. So let's dive in. I mean, you've seen these things a million times, right? Those adapters, chargers, and power supplies. We plug them in every single day without even thinking about it. But have you ever really stopped to wonder what's going on inside that little plastic box? Well, it's doing a whole lot more than you might think. You could almost say it's performing an electrical magic trick. Seriously, it's taking the raw, kind of wild power that comes out of your wall and it's taming it, transforming it from a form of chaotic energy into the precise, orderly power that our delicate electronics need to survive. And here's the heart of the challenge. On the left, you've got wall power, which is AC, or alternating current. It's awesome for getting electricity to our homes over huge distances, but its current is constantly flipping back and forth. On the right is what our devices actually run on. DC, direct current, a nice steady one-way flow of electricity. As you can see, these two just don't speak the same language. So, how do we fix this? How do we bridge that gap? Well, the very first step in our process is all about taming that wild alternating current, and we call this stage rectification. So what is rectification? It's really just the process of forcing that chaotic back and forth AC current to flow in only one direction. Think of it like setting up a one-way street for the electricity. It's the first, and you could argue the most important step in making that wall power usable. And the hero of this whole operation? It's a tiny little component called a diode. The easiest way to picture a diode is like a one-way gate or turnstile for electricity. It lets the current flow through in one direction, no problem, but it slams the gate shut if it tries to go back the other way. And here's how we use them. This is a classic circuit called a bridge rectifier. It uses this really clever arrangement of 4 of those diodes, our one-way gates. No matter which way the AC current is trying to flow at any given moment, this setup catches it and redirects it, making sure the output is always heading in the same direction. Okay, so what does this actually do to the electricity? Well, here you go. The rectifier takes that AC wave, which goes both positive and negative, and it basically flips the entire negative half up. So now the flow is all positive, all in one direction. But look closely, it's not a smooth ride yet. It's a series of bumps, what we call pulsating DC. We're on our way, but our job's not done yet. So we've got this one-way flow, but it's super bumpy. How do we smooth that out? Well, that brings us right to step 2, a process called filtering. Okay, so the electricity's going in one direction, which is great, but it's full of these things called ripples, these constant ups and downs in voltage. This kind of unstable power is still a huge problem for the super sensitive microchips in our gear. They need a consistent voltage to work properly. So to fix this, we call in our next hero, the filter capacitor. A capacitor is basically like a tiny, super fast water reservoir for electricity. It charges up and stores energy when the voltage is at its peak, the top of that bump, and then it releases that stored energy to fill in the gaps when the voltage starts to drop. And this reservoir effect, it works like a charm. It basically fills in the valleys with the energy it's stored from the peaks. What this does is turn that bumpy, pulsating DC into a much flatter, much more stable voltage. Pretty cool, huh? Okay, we are getting so close. The power is smooth, but for today's electronics, almost stable just doesn't cut it. We need one last step, the final polish, to get it absolutely perfect. And that step is called voltage regulation. See, even after all that filtering, the voltage can still drift up or down just a little bit. It might be because of changes from the power company or because your device is suddenly drawing more power. For the microprocessors in your phone, which are doing billions of things a second, even those tiny fluctuations can be disastrous, causing errors or even damaging the chip. And that's where the voltage regulator comes in. Think of it as the ultimate guardian of the power. It's often a special little chip whose only job is to watch the output like a hawk and lock it in at a super precise level, say exactly 5 volts, no matter what's happening around it. And after all that, what do we get? A perfectly straight line. Clean, steady, predictable DC power. This is the lifeblood our gadgets are designed for. This is the ordered, calm power that was created from the chaos that came out of the wall socket. All right, so we've seen the whole process, from the wall to the wire. But let's pause for a second and ask the big question. Why? Why go through all this trouble? Why does this stability matter so much? So let's just do a quick recap of that incredible journey. First, we rectify the chaotic AC to force it in one direction. Then we filter it with a capacitor to smooth out all those bumps. And finally, we regulate it to lock in a perfectly stable voltage. 3 key steps: rectify, filter, regulate. And believe me, getting this stable DC is not just a nice to have, it is absolutely critical. It acts as a shield, protecting those sensitive microchips from getting fried. This stability is what lets your device work reliably without crashing or acting weird. It prevents the kind of electrical noise that can cause errors or corrupt your data. And at the end of the day, clean power helps your gadgets live a longer, healthier life. You know, one of our sources really hits the nail on the head. It says it's all about creating stable voltage conditions. The components that are the brains of our devices, the sensors, the logic gates, the microcontrollers, they don't just prefer this stability, they absolutely require it to function correctly. So the next time you plug in your phone or your laptop, just take a second to think about that invisible journey. This incredible transformation from the chaos of AC to the calm of DC. It's happening constantly, right under our noses. It kind of makes you wonder, right? What other hidden processes are out there, quietly powering our modern world?